Hey, so this should be interesting. What we have here is this is a Hewlett-Packard 16700A. It's a logic analysis system. This thing's pretty funny. It runs an old version of, I think it's HPUX. It's the Hewlett-Packard version of Unix. It's got a couple cards in it. We'll get to those in a minute. It's actually got a, what is it? It's got 2 logic analysis cards and apparently a 1 gigasample per second dual channel oscilloscope. Go figure. So this thing's pretty hilarious. The boot process is quite interesting, and I'll show that. We'll just take a look at that in just a minute. But yeah, this is kind of an interesting behemoth. Just a fun bit that came out of the rubbish. So it boots up and everything too, though. God knows how long the hard drive is, how old the hard drive is. It's probably not good for more than maybe another 20 minutes. So, first of all, holy shit, fans. Listen to that hard drive. SCSI, it looks like it uses SCSI drives. 150 megahertz CPU. Interestingly enough, it won't boot properly. Oh yeah, HPUX. That's pretty funny. So I bet this is memory offsets or RAM. Yeah, HPUX B.10.20. Interesting, it's Agilent branded. Oh wow! Checking for LVM. This thing uses LVM. I didn't even know it was around at that point. So interestingly enough, if you don't have a mouse hooked up, it won't even launch the X session. It uses classic X11. It's got a HTTPD. It's got a web server that isn't running. Never mind. So this was actually fun. I actually had to spend a while trying to find a PS2 mouse. Because who the hell uses PS2 anymore? Yeah, check it out. Classic X. So now we get a window. Oops. Network not configured. So it looks like it has a web remote front panel. There you go. So it looks like our date of relevance here is 2000. RTC is wrong. It is not 2005. Hey, calibration relays. So I wonder, this must have been around when HP acquired Agilent, because it's still got all this Agilent branding. Also, hilarious ancient ass grotesque cursors. Fun shit here. So we have a 2 mega sample, 140 megahertz state, 500 megahertz timing card with an expander card. So this is a 16557D, and then we have a 1 gigasample per second oscilloscope. Target, control port, port in, port out. I don't know what those do actually. That's pretty funny. We can go here and we can say set up display. Christ, this thing's noisy. And we get like a fancy oscilloscope window. I don't know. Oh my god, it's got Netscape. So I don't see any way to change the screen resolution, which is kind of annoying because this is a 1610 monitor. But anyways, so we have our funky little window here, and we can go back over here and say run repetitive, and then now we get, you can see this is updating periodically, waiting for trigger. Let's set that to 0. Set that to 2. So actually, why don't I shove a signal in this thing? So I don't have any of the logic. Well, I don't have any coherent logic analyzer pods for this, unfortunately. So, while I can give it a poke, I don't think I can actually do anything interesting with regard to testing the logic analysis subsection. Not that I really care, considering you can get a $300 or $400 logic analyzer that channel 1, there it is. A $3 or $400 logic analyzer, or hell, even a Sele logic will do most of what this does. So I should have a signal. I don't know what my X. Let's see. Yeah. Right about there. My output is 4 volts peak to peak. Well, let's stick a phase offset of 90 degrees. I think that's what I input. They're both 1 kilohertz. I got something. So they're both offset of 0 millivolts, 90 degrees out of phase, 4 volts peak to peak. Oh, I see. I think I see what's going on. Let me go to setup. Oh, 1 mega ohm. Okay. Where is my? Oh, hey, all sorts of funky crap. So how do I set my horizontal time base? Oh, here it is. Let's zoom in. This is zoom out. Okay, yeah, so I am getting a sine wave. I think it's assuming I have a 10x probe. So let's go to 20 volts per div. Okay, yeah, now it's working. Yeah, cool. So we just have a nice little sine wave there. So channels. Oh yeah. So there we go. Now it's properly interpreting. So now they're both set. Let's set these to 0. Let's set it to 1. Cool. So we have a pretty, it seems like a serviceable oscilloscope. It's, I mean, the real issue with it is my regal is like 20 times, 100 times the performance, and it doesn't have, it's much more compact, it doesn't have as big of a fan, and it's got way more memory. I actually don't know what the sample depth on this is. Sure is a cool, it's a pretty cool bit of kit. Is this at the ultravision point, or can we get it to alias? That's pretty good. So it looks like, you know, whatever the date, this was at the point where they had a high enough sample rate that they didn't have issues. I wonder what the actual functional sample rate is right now, because I'm feeding it 100 kilohertz signal and it's not aliasing, which is quite nice. Let's take it up a notch. No, it's aliasing a little bit, but that's at 1.6 megahertz. Let's go 10 megahertz. Oh, no, never mind, aliasing. So, that's kind of disappointing. So, it looks like, I mean, I guess they're doing oversampling, but they're not quite up to the point we'd need. So I kind of gave up on trying to get in here and get into get a terminal prompt in this thing, just because it wasn't really working out. Apparently HPUX is pretty locked down. So what I'm gonna do is just pop the lid off and just take a look. So anyways, you can see here are the modules. Ooh, interesting. Okay. So, so here's the back plate. Whoops. So you can obviously see these are 16557D, 2 megasample per second analyzer, 135 megahertz state, 500 megahertz timing, and apparently these can be wired up as slave. You have these SMC, I believe, no, sorry, SMB connectors, which are your clocks. Here's the oscilloscope, 16533A, 1 gigasample per second, with some kind of a little bit dirty BNCs. I think this is trigger, though it's not explicit. Down here we have, don't know what this is. Here's the informatively labeled port in and out, expansion frame, keyboard and mouse, empty blanking plates. Then I think this whole section here is the motherboard. RS-232 monitor, parallel, 10 base T, slot location, SCSI 2 single-ended, and then we have a token ring, or not token ring, whatever it is, 10 base T coax. But anyways, over here. Oh yeah. So, card cage, motherboard. There's a couple different boards in here. Actually, looks like an IDE connector. Big connectors. And then over here, Down in there you can see the power supply with lots of big simple color heavy duty cables. So let's see if I can pull this further apart. It's a big, huge, noisy fan. And then there's another card cage in here for these two blanking plates. And then in here we have ribbon cables, lots more huge fans. Lots more huge fans. And then there's the card cage. And then that big ribbon cable goes to the rear panel. This is quite interesting, so we can start to see here some of our kind of the various boards. I would bet that this here is actually the processor. It looks like we have RAM here. This seems to be a special purpose board to interface with the backplane, which is up here. You've got a hard drive with what looks like a specialty interface. This may be SCSI, I'm not too sure. These two ribbon cables are the cables that talk to the front panel. So, yeah, I don't actually know what this hard drive cable interface is. I'll have to look, but it could very well be SCSI. I haven't done a lot of work with SCSI. Yeah, so this is a quantum. I don't see the size marked anywhere. But yeah, it wouldn't surprise me if there's like some sort of standard. I mean, this looks kind of like XPCI, or excuse me, PCI X, just in a funky form factor. We have two big connectors here, which I would guess are for some sort of additional expansion. And then this is held on with pop rivets, but that looks like RAM. We've got a lot of huge connectors. Look at these big connectors here, here. And we've got these huge interconnects between the two boards. Interestingly enough, this board here, which has a bunch of special purpose, so we have AMC PCI Matchmaker S5933QE 9836 LVO. Here's a couple big Xilinx parts. XE4010E, XE4010E, so these are both the same parts. We've got that's probably just an EEPROM, or even maybe a PROM. This is an AMC Q240080020, and then some big, these are either maybe resistor arrays. So right here you can see, right here is the SCSI interface, which is what all these traces are. So that's probably, oh hang on, I know what's going on. So we have an SCSI bus, so it probably comes in here, because remember this is a bus, runs past this hard drive, continues on, comes back to this connector, and then runs out the back panel. I actually wonder if this should have a termination on it. And then under here, this part's proximity. So here's your transformer magnetics for the Ethernet. It's 150 megahertz CPU, I don't know much more about it. Here's your floppy drive, various bits and bobs. Actually, I think this whole thing, I don't know if it slides out or not. The computer section does. Alright, hang on, let me take this apart further. I'll plug the external monitor back into my camera. kind of an interesting architecture. So these two backing plates, I don't see where they'd ever connect. Oops. So this. So this is quite nice because they've got these teardrop sections here so that the board slides and then just lifts. Power supply's down here. Oops. The power supply's down here, and it looks like an off-the-shelf module. You can see you've got a screw terminal lugs in here. There's two 60mm high power fans here, and it looks like there's some modules in here. I'd like to try and get the power supply out. I'm assuming there's only one fan here, so you can see that this is power in here. So it's just there's a big mains connector here. So the power switch on the front panel of this is actually a soft power switch. You turn it on and it boots, you turn it off, and then it shuts down gracefully. Floppy connector to floppy connector, eh? So this board down here is just a straight up interconnect. So you just some caps over by the PS2 connections, and then just this looks to be straight through. And then this smaller ribbon is the PS2 and the BNC and the general I/O, whatever the hell that is. And this looks to just be the expansion connector. So this actually looks like it just slides in and it slides over and then just lifts right out. Alright, so here are the electronics out of this thing. We've got the various cards, backplane, and here's the power supply. Why don't we just kind of let's start at the power supply just because that's kind of interesting. And I can kind of do a reverse reassembly while I'm going over the various boards. So this is really quite the interesting power supply. It's a just a huge, just a really rather large piece of kit. Also, it's obviously like a configurable model power supply where you can probably have them stuff a bunch of different output modules in here. And then it actually looks like these connectors just go into an output kind of distribution thing that comes off of these I mean, this just looks like a two double-sided PC board. And then I'd guess that this connector here, that's probably like power control or something along those lines. Some of these seem to be ganged together in interesting ways. Actually, if we look here, we can actually see that ganged together thing is shown here. So it looks like we have 5.1 plus 5, negative 5 coming out this connector here. Look at all these COM pins. Plus 3.4, and then over here we have plus 12 and negative 3.3. Do I see any current ratings? I don't. Weird. It does say 12 amp max at 115 volts, which is that's like more than a kilowatt. That's a lot of power. Mounting hole. So you can definitely see this thing is some sort of modular construction, actually. Incidentally, this is AUTEC Power Systems, AUTEC Power Systems. Oh great, it's held on by the fans. Alright, yeah, so there we are. So it does indeed look like we have, yeah, 5 volts, 5 volts, 3.3 volts, 3.3 volts, 3.3 volts, 12 volts, plus or minus 12 volts, correction. Yeah, wow, these are, this is pretty cool. So this is very similar to this the giant DC to DC I took apart, in that it's got a back plane with your kind of your high voltage DC supply, and I would bet that this is power factor correction. Also interesting, look at this, they've got, for mechanical support, they have foam pads on the top to hold some of these in place. Like this is to hold this vertical card, which actually does wobble a fair bit, and this is to hold this huge, really just absolutely enormous inductor. I bet that's part of the active PFC. It's also sitting in like a plastic box filled in with epoxy. Giant ass bridge rectifier. You know, input comm mode and rejection and chokes and so forth. And then these are all the little kind of sub DC to DC modules that probably provide the isolation. 5 volts, 35 amps, 5 volts at 35 amps. So I bet these two are, because from the output specification it's got plus 5 and it's got negative 5. So I would bet that these two are stuck in series, with the center point being the ground. In fact, that would seem to be reinforced by this circuit board, where you can see you have terminal here, this terminal here is connected to that terminal there, and then that terminal goes down there. Also see there's a wired jumper across there, so that would mean that this common here is shared with this common here, and which actually looks like it also runs over to this point over here. But you can see that this plus and minus 12 volt supply has 3 output terminals, and the rest of them all have 2. So, it looks like our two, or in fact we have plus 3.4, plus 3.4, negative 3.3, as well as plus 12 and minus 12. So my guess would be that these two supplies, which have this jumper between them, I would assume that these are in parallel, and that's what this jumper enables them to do. This is probably referenced to the ground, so that this is your negative 3.3. And then this is plus 12 at 5 amps and minus 12 at 5 amps. And that's quite just really a lot of power. It's a cool power supply. But I mean, look at how many wires they're using. I mean, I guess they don't want any voltage drop. It doesn't have remote sensing, so I guess they need like the lowest ridiculously low impedance connection they could possibly pull off. And then I would imagine these modules kind of come out, but I don't really want to take it apart too much further. Okay, yeah, if you look down in there, there are rectangular connectors down there. You can see they're actually blade connectors from the look of it. But that's the, so there's like an interconnect back plane down there. It's very much the same thing. It's, I think, a power supply. It's probably a little more expensive than normal, but you can kind of have the factory configure it for whatever kind of, you know, whatever output rails you want. It's a big glob of silicone that taps off the top of this transformer. And then this is probably like a control board. Actually, this is it's probably a diode because it's only got 2 leads, but this seems to be a, you know, some active switching devices down here which are just clamped to the side of the case. You can also see this ribbon cable here runs all the way up and then joins right there, which makes me think that this interface is probably like standby power and power on control or something along those lines. And you can see you've got a, oh, that's nice, it's an HRC fuse. It's a very nice, this is a very nice piece of power supply. You know, even if the Logic Analyzer is useless, the power supply is definitely worth it. And then we have two brushless DC fans. These are like the really thick ones, which are probably, you know, really high air velocity, but they're also noisy as all hell. And then this case just kind of plops down there. You can see the fuse is partially exposed, so you can change it. It's a nice bit of kit. Don't bother. So that installs into this bracket assembly, and this is obviously just the back plane, which is, it's just exclusively, you can see power inputs are here, and then we have a couple, okay, these are all diodes. They're labeled CR. You know, they could have been something else because the tabs are obviously bolted down. But actually it looks like this meshed area here, +5, -5.2. And then you can see on this end, this is where the power supply connects in. And one thing you might notice here is this, basically the open areas have little copper squares all over them. And that's to keep an even copper distribution, or a fairly even copper distribution across the surface of the board. It's a manufacturability thing. Also interest is, I don't believe I took anything out of these 3 screw holes. But anyways. So this is quite nice. Sorry, it's kind of hard to see in here, but as I'm putting this back together, I'm realizing that most of these things have these little alignment pins, like so that all the screw holes line up, so that should drop into that hole there. And then that basically just makes sure that all the screws are lined up and everything. There we go. Oops, and then it fell back out again. It's really, yeah, there's actually 2 here. You can see there's one up here and there's one down here. So that's how they make sure that everything is aligned properly by not relying on just the screws for mechanical alignment. It's very nice. It's very beautiful design, you know. HP built up to a standard, not built down to a cost. So these are this is the CPU. So this forms the CPU of the whole system. You can see here you have the processing board. I'd guess these are like PCI or something along those lines. You have this board, which is very interesting in that basically these two plug in together. It's a really stiff connection. There we go. And then this interesting kind of board here partially plugs in here, and it also plugs in here. Like so. So it kind of forms another interconnect path. Really, it's a remarkably complex assembly. And then, you know, so on the back here we have, this is the external SCSI interface. And incidentally, this connector here goes to the internal SCSI hard drive. So actually what I kind of suspect is going on here is, I can't really see. Okay, yeah. So I think this is the SCSI interface, the SCSI interface. It runs up to this connector. So it comes from here, which is probably related to this chip here, 1FT10002 NPFT1C8613A 9822. That's probably 1998 week 22. So I think that's the SCSI interface, because if you look down here, you have a whole lot of parallel interconnects that run to this connector. And then, remember, with this hard drive, you have these 2 ribbon cables which bus past, sorry, it's out of focus, which bus past here and then come back. So these 2 connectors are functionally in parallel, they just run by the hard drive. So I think, you know, because remember SCSI is a bus, I think what happens is it comes up here, runs out this connector, comes back this connector, and then finally runs out this external port past these two devices here, which I bet are switchable terminators. So I bet what happens is if you plug something in here, it removes the termination, and then you have to terminate the bus yourself. But it's quite the topology. And then you can see here we have +5 and +12. So this is a floppy drive style connector, which then terminates to a Molex style connector, which then runs the hard drive. Because apparently it wasn't complicated enough already. So those devices are I'm gonna have to get the macro pins out. Okay. Please stand by. I'm gonna have to switch lenses because I can't make this out. But anyways, we also have, that's interesting. So this is a coaxial 10 base T interface together with a little DC to DC, which appears to be silicone down to the board. We have a bunch of TTL logic, differential pairs from the look of it. Still out of focus. It's kind of annoying. Yeah, so I bet that's your, well, yeah, that's got to be your token array. I wonder what this transformer's for, because it's not the Ethernet interface, because that's on the other board. And then we do have a few scattered nice loop test points. There's one here. And then there's these big things here, which are marked DL 1, 2, 3, and 4, which have no apparent connection, and each one only has 6 terminals. Yeah, so there's a test points all around here. A whole bunch of tantalums, resistor arrays. So here's the main CPU board. You've got all these interfaces, which I bet, you know, I'm guessing based on absolutely nothing that they're something along the lines of PCI. It could be ISA, though it is 2000, though I guess a lot of the stuff took longer to update. These really enormous connectors. Very stiff, enormous connectors. You've got all that, you've got crystals, battery back. Here's the Ethernet interface, 10 base T, and there's your transformer. Probably Northbridge. These two connectors are entirely unused. Big heatsink, and then we have a RAM expansion. So I'm pretty sure this is like CPU RAM. I think I was looking under here and it looked like they had some on board. Oh yeah. There's the soft rubber end of the... There it goes. Yeah, so this appears to be, you know, the completely non-standard, you know, replacement for just like whatever the RAM pinout was of the time. And it's just held in, as you saw, by 2 plastic clips. We have debug header, maybe. Stuff is glued down. Lots of proms. Here's some DC to DC. So on and so forth. The other side is equally busy. More devices. Big HP branded parts. Here's an Adaptec part. More SRAM, I'd imagine. And then here's this amusing little wire fix. Let me see if I can't get the processor heatsink off. Hold on too aggressively. I think this is just a Pentium. Wow, that just fell right off. Alright, so we have something hard soldered down to the PC board. This is not a very substantial heatsink. And look at that, there's no branding on the CPU at all. That's kind of surprising. I wonder, this might actually, it might be like a, no wait, there is branding. Let me change lenses. So I had assumed this was x86 of some sort, but looking at it, it's a Hewlett-Packard branded processor. This might be like Spark or something particularly esoteric. It's a complete, the die is unmarked, 1FE40010 Singapore. We have 5180-7362 Rev B. So I bet this is like an Intel, or excuse me, Of course it's not Intel. Intel would be Pentium. This is probably like a one of Hewlett-Packard's obscure legacy. So here's the previous lens. You can just kind of see the overview of the various parts on here. Here's all the RAM. This is the bottom side. There's the fixed wire, Adaptec part, Hitachi parts. Actually, now that I think about it, these are both the same devices, which is interesting. Crystal devices, and then over here we just have various oddments, CMOS backing battery. I wonder where the RTC is. I didn't see any RTC crystal, but we obviously have an RTC battery back. I might have missed it, or it might be baked into one of these components. This appears to be square in profile. So this is the board that connects between the CPU board and the backplane. So you can see here's that this is the backplane connector. And one thing of interest is you can see over here we have a whole bunch of ferrite beads in parallel. And actually if we flip this over you can see that a lot of these connections are hugely ganged together. So this is going to be where the power comes into this board from the backplane. And then it presumably routes through this board into these connectors into the CPU board. Another thing of interest is the back side of this board is completely empty, except for this big pore over here. These two big connectors I'm fairly confident would go to modules that go into some of the unpopulated slots. There's the two smaller slots on the side, and there wasn't anything in there in my unit, so I think that that's what those connectors are for. You can see here some of these huge connectors. This is a 100-pin connector, J13. You can also see some of this layout. It looks like some of this must have been done by hand to some extent. I guess it could have been at least partially auto-routed. So I mean, you don't see angles like that where it's not quite a 45, in auto-routed boards generally. It is kind of messy. Like they should have, if I was routing this, I probably would have brought this trace around and then took that trace straight up, but it doesn't really make a difference. Here are some of these connectors on this edge, and you can also see some of this copper fill stuff going on. So this connector here is for the power to the floppy drive, which is why you've got this big heavy strap. And this connector here actually goes to the front panel switch. If we flip over, you can see here that goes to the front panel switch. So one of these is going to be the LED, which is probably these two pins, and then these two are, I would guess that's debouncing for the power on. So then we have a whole lot of stuff going into this big backplane. Lots and lots and lots of resistor arrays. So it looks actually, I think I know what's going on. I strongly suspect this entire interface here is completely floating, because you've got a transformer going into it, and then you've got a what looks like a DC to DC, though of course the power is running across this isolation gap, which you can kind of make out, which is poor practice. That's kind of sloppy of them. A lot of big resistors, 261 and 261K resistors in series, and there's 4 of them. That's weird. That's about it for this board. There's just more, lots of 74 in series. There's a Max 910, 86A13TF, F32, lots of logic on the bottom. This is just TTL logic. And I'm going to put this stuff back together and then we'll get into the interior. Yeah, so those 2 connectors that are down here are definitely accessible from underneath, so I'm pretty sure that's what the 2 things that go here that I don't have are for, or where they're supposed to mount. So now we're on to what I'm sure is the reason people actually wanted to watch this in the first place. So congratulations, I've managed to put you off for like what, probably 30, 40, 50 minutes by now. So this is the oscilloscope board. You can obviously see it's pretty complicated. We've got really interesting, some sort of ASIC devices under here. I'll probably try and take one of these off. What that is, it looks like a bodge board. It is a bodge board. There used to be, oh, that's hilarious. So this is a board, and under that board is another board with BGA, with what is it? It's a oh, I forget. It's one of the many pin packages. If you look on the other side of that, you have this. So I bet this was like a specialty ASIC that they couldn't buy anymore or something. Also kind of interesting is, look at this, we have these ribs on the bottom. But there's a lot of interesting layout here. You can see we have some big, these are 15R0 resistors over here with big traces. That must be some sort of current sensing. This is a little bit rusty. And then we have, you know, gold plated. This is a beautiful board. Here are the front ends. There are relays in here. I can hear them clicking if you change some of the settings. You've got a ECL external trigger in and out. Oh, that's amusing. Oh, this is AC/DC Cal. So these are all, I believe it's called SMB, but they're basically push latch. So you kind of have the connector and you have this, and it's good up to RF, and they kind of just push on. But yeah, so you can see here is that interesting, and you can see it's got like another board under there which serves as like the interconnect. That's pretty hilarious. And then we have some other interesting stuff. This may be a resistor array. These have to be, oh wow, look at that. It seems like it's like an ASIC sitting on top of, or some sort of a heat sink sitting on top of some sort of funky ASIC. It's too small. It's too big. It must be the one that's in the drill. Looks like a power. There it is, yep. Let's take the heatsink off here. Oh wow, this is quite intriguing. So we have some sort of metal clamping apparatus And then, oh yeah, look at that. It's got like a finger that pokes down and makes contact with the surface of whatever's in here. And then this, I wonder if these are removable, considering they seem to be in like some sort of socket. That's interesting. Look how long that screw is. What holds that piece of metal in? Are those... Okay, so these appear to be threaded inserts. Where are my nut drivers? Over there. Nope. This is just mostly, so far, it's been quite nice in that it appears you can remove these without removing a lot of the socket mechanism. So these are the analog front end, I would assume. Oh yeah. Wow, look at that. Isn't that like an esoteric? Oh yeah, and look, we have like pogo pins in here. So this is some sort of specialty mimic, or well, I guess it's not a microcircuit. It's a custom hybrid IC module, 1N878. Fucking 8353, and then you can see it's got basically traces running out to the edge, which are basically pad connections. Let me change lenses. So here it is. You can see these interesting traces kind of coming out around the edges. 1NB78353. Don't really want to try decapping it because I wouldn't mind this. Well, we'll have to see. I may make a follow-up. But yeah, and then you can see it sits into this socket with these special pins in it. And then there's obviously a gold-plated section on the back for heat connection. This is ceramic. Incidentally, it's kind of gotten filthy. And then it's got like this many-layered stack-up clamping assembly which runs through the board. This forms the main clamp. I guess these are pressure distribution. It's interesting that with all that stuff going on, there doesn't appear to be any heatsink paste on here. Oh, and then those holes poke through there, and then this spring just applies force right in the center. Man. It's an elegant assembly, but it sure is complicated. Nowadays, they just glurp some hot heatsink glue on there and just say, okay, I'm done. I wonder, I guess these are only exposed because they wanted the heatsink to mount closer. Because it's not like by, you could take these two screws out and lift the thing out, because these screws go into standoffs which also hold it in. So there is that big funky hybrid thing, which is a Japan 1821-4786. I'm trying to get the RF front, or it's not an RF front, I'm trying to get the analog front end off. And it actually appears, yeah, look at that, it's another one of these horrible, these are common in Hewlett-Packard things. So there's your switching relays, and then there's it's all built onto like a piece of, there's a ceramic with thin film resistors and stuff stuck on there. And then this is just, so this is your input can. This is common, I've seen this in some other Hewlett-Packard stuff, I've taken it apart. So that is a L293, that's hilarious. So that's a quad, excuse me, it's a dual H-bridge chip. And I bet they're just using each, they're just using all those H-bridge halves to drive the, all these different relays. Let's see, is there any easy way I could get this apart? It seems like these are, Oh, it's just a spring. Oh, that's hilarious. Yeah, so here we are. Here is our... so we have these two little metal springs down here, which are just connectives, connections. And they just sit in those two little slots, and then these gold tabs press against it. And that's how you get it really aggressive, like a ground along a whole strip. And then you have these two little side panels that hold it in. And then under that ceramic cap is going to be a lot of the amplification. Let me change slightly. Yeah, so here's your input network. So you can see you have all sorts of really kind of wild servers. I mean, this black substance here, I believe, is like a carbon resistive compound, and then you can see how it's removed. I believe it's etched away with a laser. There's lots of stuff like that. You can see, I think that's laser etched. It looks like this is like a tuned end of some sort, and they blasted away with a laser. KKW or M, yeah, it's KKW. You can see it's ceramic, and then these are probably the DPST relay terminals of some sort. It goes into this big ceramic covered thing, which I didn't really get into, unfortunately. Yeah, if you look here, you can see that this is actually two layers. There's a layer of gold, and then they deposit like a layer of ceramic glaze, and then they deposit another layer of gold on top of it. Let's see, any easy way to get in there? I think these... fuck. I strongly suspect these big terminals here are the relay coils, and these small terminals are the actual pin connections. If we flip this over, can't really see into the relay that well, unfortunately. Yeah, but it looks like the relay. Okay, yeah, so the wire terminates here, and it runs across, and then it terminates there. So these big pins are the relay coils. But you can see here we've got, looks like, I bet that is your switchable input 50 ohm terminator. So I bet that's what this relay does. And then you've got attenuation connected to ground, some sort of inductiveness tuning, and then these might be forming a capacitor. I don't know why this is passivated, it seems like, or coated in something. I wish there was a way to take that cover off without totally launching the thing. Yeah, anyway, so that's pretty cool. And then it looks like there's just a, in here there's just a metal post which this spring pushes up against. So the people complaining about it being out of focus when I'm manipulating stuff, I know I'm sorry about it, but I have to look away from my monitor. I have an LCD monitor showing the video signal over there, and often I have to actually be looking at it directly, and in which case I, to manipulate it, and I can't be looking, paying attention to what the monitor is showing and, not breaking it at the same time, unfortunately. I don't actually know what that hole's for. It's probably for another system, another setup type thing, because I would bet that there's like a adjustable something in there that I just don't have on this particular setup. Let's see, that just fits down there. You can also see here we have more like EMI shielding. These are just like it's a grounding strip of some sort. Kind of sits in there. Lots of oddball stuff. That looks like it's probably a little relay or something. Down there, that is another, an 8706. The whole thing is very dusty. I'm going to do this tomorrow. Carrying on, we've got MC10E1652FN. I don't know what those are, but they're interesting. There's a whole bunch of them too. There's a 744, 317, HP R820. That's interesting. That's in a JLEAD dip package. But that's like a relay of some sort. There's actually one over here on this channel as well, along with another 8706. Big passives. There's a high power. Here's more of these. They really like PLCC, I guess. PAC 9846, PM 9902. 9902, various things. This is this interesting BGA replacement thing, which is Japan. I don't know which one of these is the part number. National 78AD. UCC 284. This is a 50 megahertz canned oscillator. Over here we have a big TI ASIC of some sort and a 100 megahertz crystal. This is fairly interesting. We have an L272, but it's got these two spade lugs. And I almost think these spade lugs are here for heat sinking, which is very unusual. HEL33. Interesting trace layout. I mean, these looks like they've been hand done. Here's a big something in like a SIP package. Soda. Some Actel devices. That's probably a CPLD of some sort. A102OB, PL84C, blah blah blah. Fair amount of logic. This looks like just TTL stuff. 10KHT5578. Actually, I don't know what that is. PA9903, 9638, 9902. A lot of this seems to be like a series of logic. Ooh, that's interesting. Here we have that's an 809667, and then we have three transistors. Though it's worth noting that this device appears to be like a pair of matched JFETs or something like that. It's a 6-pin package. Let me see if I can figure out what those are. Oh. It's marked, I think, F9752AC. And this one is 9806. Not sure what they are. They're all marked Q, so I think that's why they're JFET. This may be like the offset DAC or something. We have another 8706. Sorry, 7400 series logic. There's a whole pile of analog VREGs. LT1806. 337 negative. I don't know what that is. It's linear, but it's got a hit. Here's another 337. Another one of these. So these two are the same, and these two are the same, and that is a 1806. Lots of TANTs. I don't know where the SRAM on this board is. Here we obviously have just, you know, backplane I/O buffering. There is a battery-backed RTC here. This is interesting. It's a big ferrite co-inductor. We have a calibration memory protection, which may be also in here. ISJ 102, 9802. It's interesting. It's a long dip. It's like a dip 28. There's an OP400. 8706, 706, 706, 706. I really like the 706. There's an 8586. And that looks to be about it for this board. There's nothing on the other side. One thing that is interesting, as you can see, it looks like there's, I think it's current limiting, not current monitoring, because here's, you know, there's a polyfusions, here's the, because, and I don't see Kelvin connections or anything, but that's kind of interesting. Yeah, we definitely have a couple polyfuses and lots of these long surface mount ferrite beads. So 2 VR plus 2 VR plus 7.3 VR, negative 6 VPR plus 6 VPR. So it looks like plus and minus 6, plus 7, negative 2, and plus 2 are the voltage rails on here. Wow. The board is kind of filthy. There's so much airflow through the case of this because of the huge fans. But yeah, it definitely looks like there's been some hand layout tweaking. This is an interesting part. It's not marked. I'm going to pull the sticker off. But it's another one of these like custom parts, like the whatever the big embedded array thing is. Oops. Blah. That just plugs right in. And then here we have the Logic Analyser boards. So the architecture of these boards is pretty readily apparent. You've got inputs probably differential termination line of some sort. Big, probably data acquisition ASICs. This probably handles triggering RAM, and then probably readout logic of some sort. And then you've got, looks like some switch mode power supplies. So here's this interesting section where you can see here, this is how the two, the two identical cards are hooked together. So you can actually see these two cards are exactly the same. And it appears that, oh, that's quite interesting. Yeah, so you can actually see here, this is expand, expand, master, expand, expand. So I would guess that by hooking this port here to the port labeled master, that sets this as the master. And by hooking this port here to the port up here, that, so it looks like one master card can control 4 expansion cards, which would make sense because this has a maximum of 5 slots. So I would expect that to be architecturally dictated. But I also think these two cards are completely identical. So I'll put this over here for the moment because we only need to look at one of them. So input section, differential matched pairs, which makes me think it's differential. You also have pair matching here. So there's probably slew rate matching, because remember this runs at can run at up to 500 megahertz. You've got series resistors here, which look like they're probably controlling the source impedance for these signal lines, which are then probably terminated in here. You've got some interesting traces running back and forth. We'll get closer in a minute. So these are the external clock input, I believe, the reference clock. We have reference out and reference in. And then back here, this looks like the crystal that's used to generate. This is very interesting. I don't know what that is. Maybe someone in the comments can fill me in. RAM. And then we have big voltage switching, probably switch mode voltage regulator, though that may be involved in that. Or a whole bunch of inductors. This might actually not be switch mode, though this has 5 pins, so I bet it is. Probably runs most of this. Obviously you can see there's a lot of this. Also looking on the bottom, you can see how enormously wide some of these data paths are. Look at the pitch of that. You can see also we have, the other half of these signal lines. They may actually not be differential because I'll have to look more closely. Look at those though. Right, let me change lenses. So here we are looking at the bottom. I almost think some of this was done with tape. Because you just look at how some of these, no, I guess, I don't know. They look kind of very serpentine. They look a lot like what you get with tape board layouts. But man, look at that. So we have traces here which run from here. Well, it looks like they all pass through this one. I wish I had a paintbrush or something to clean this. All right. The dust is like caked on. But you can see we run past there. Man, look at that. They're fitting 2 traces between some of these pins. That's crazy. They run down here and then they run into the other one. They run across and they go into this right here. So I bet this is some sort of really... Well, no, wait, actually, this is probably clock sharing because these are the pins that go down to the other modules. That's pretty trippy. So yeah, actually we can see that there's, look at how many pins, Q, W, X, C, C, E, E, F, F, G, G, so many pins. This is, it's 35 pins in each direction. Wow. Here is this enormous bus going into the RAM. And you can see here, these are the pins along the RAM. You can see we've got bypass caps for the SRAM. Over here are these input buffers, which are HP branded 1NB4-5036, NPQV6A8109. And then it looks like this interesting assortment here is input termination. So we have like RC, RC. So this is probably, you know, some careful control of, I'm not too sure. That's interesting. It actually looks like, I think this end's probably grounded by that, so the V comes in there. Yeah, but anyways, you can see how they're matching the length of all of these input lines. So basically the distance between where it comes in on this pin and when it reaches this chip is the trace length is going to be exactly the same for all the different lines. So this is very interesting. It looks here like look at these thick traces. That looks like that's controlled impedance almost. So this may be like a transformer or some sort of inductor array that handles impedance, controlling information. Goop ICS. Also interesting is down here. Oops, there it is. This is so this is that master-slave thing going on. You can see we've got some interesting. Man, that's probably hand soldered. So here's the other section. Don't know exactly what's going on, but it goes over to this very interesting assembly here, which is just a bunch of fairly large. These are like 1210 resistor. No, wait, no, they're. It's 0805, but they're like wide 0805, and they're all in parallel. Look at that. There's one big bust on the middle. That's quite interesting. And there's actually a chip right here as well. See more interesting stuff. Okay. Here's some more of this very organic looking trace layout. Man, the amount of hand layout on this is insane. You can also see down here we have some very interesting, like some clock slew control something going on. Gunk on here. HEL16XCSV. But these are the interconnects to the two other board layers, and you can actually see here was the cutout, and there was the breakaway tab. Interesting. And then that's about it for the bottom. Flipping over to the top, we have, so these are double-side loads, so we have them on the top and the bottom for all breaking out all of these pins. Actually, if we look up here, here is that part with all those resistors on the underside. That is a, let's see, where is it? MC10E111FN. And over there we have an 807226LP. So some of this may set logic thresholds, because I bet these are well, I don't know how much of this is done in-house, in here, and how much of it's done out in the logic acquisition pods. But we've definitely got, there's an OP400, I think we've seen those before, and then these two devices, which are, apparently look like resistor arrays. There's an 8586. There's a whole bunch of big tants. It looks like differential pair almost. So I wonder if they're feeding like the acquisition clock through some of these connectors. That may be what these HEL16 parts are. Down here we have MC10E101FN. And then, man, I gotta hold this up a little bit high. So here's this interesting, oh, you know what this is? This is like a differential to single-ended transformer. Because look, you've got what looks a hell of a lot like differential drive, and then, yeah, and then this is single-ended. On the other side, yeah, so on the other side of this interesting assembly there's a, let's see, where is it? It's right here. So you just have some surface mount resistors. So I wonder if those are actually grounds of some sort. I'm not sure. But that's quite interesting. I bet this is some sort of RF something, because you can see here we have, this is obviously our internal reference clock. It's 100 megahertz. Then we have ref clock in and ref clock out, and this is probably some sort of clock switching or something. You can see, and that might be power considering how they're strapped together. But there's, this is probably clock switching of some sort. So we have a 100 megahertz canned oscillator, and this is a 19.0608 megahertz oscillator. 19.6608, correction. That's a weird frequency. So over here is this big Actel device on the output, which is A1280. And that looks to be connected through to this big parallel interface. You can see traces running through. Though some of them may actually run straight to the RAM. And then here we have this huge bank of RAM. It's all OKI 5416283-60. They're all the same. They're huge. And then here's these two HP, these two big HP ASICs, the acquisition ASICs, which I have not been able to pull the top off. I bent my spudger that's really glued on, and I don't really want to totally risk breaking something because it does still work. Yeah, it's interesting. This may be like a strange early fiducial. I'm not too sure. But anyways, yeah, you can also see we have some of these not surface mount ferrites. Oh yeah, and then the last area of interest is down here. So this is MMP2902, and then we have an LT1170, and then this is that looks to be a diode just from, yeah, CR1. So I bet this is like a DC to DC for whatever the core voltage is, and we have a whole bunch of capacitors. And that's just a capacitor off in the middle of nowhere. Yeah, look at all the memory. Well, I mean, this thing does have 2 megapoints of memory, so I mean, or 2 megapoints of sample depth, so it's got to have a pretty considerable amount of local storage, especially in, you know, the point at which it was made. So I guess that's what all this is. Anyways, it's pretty cool. It's interesting looking at how complex this stuff is. You know, how amazingly involved all of the layout is. I hope you found this interesting. Yeah. So let me know if you have anything you want to share down. I've got one more thing, well, 2 more things in the pipe, but let me know. Or mail me stuff, ideally.